So today's topic is composition of functions. Okay. So functions we can create by adding or subtracting or multiplying or dividing two or more other functions. Right? So we can create a function like this. F at x plus g at x. That still will be another function. And these ones we've done. Okay, so let me clarify the domain of these functions. Okay, so let's say the domain of the function f is df, and let's say the domain of the function g is dg. What do you think the domain of this entire new sum of function will be? So the word domain means they're valid inputs. So let's say I found all the x values I can put into f. I found all the x values I can put into g. So what can I put into both f and g at the same time? Only the intersection of between these two. Only the numbers that are satisfying both these equations. Okay, so that you say the intersection of domain of f and domain of g. So let me give you an example here. Let's say we have y is equal to root of x plus root of 1 minus x. So you can think of this function as a sum of two functions. The domain of that is x is from 0 to infinity. Okay, and the domain of that is x is actually less than 1. Okay, so graphically it's like this: 0 to the right of 0. This one here, 1 to the left of 1. What x values are satisfied in both conditions? Do you see that it's only between 0 and 1? Between 0 and 1, it is greater than 0. Between 0 and 1, it is also same time less than 1. So this is your new domain. Okay, 0 to 1. So this is how you find sum of two functions domain. It's the same thing for subtraction as well as multiplication. Okay, let's consider this last one, the division. This is a little bit different. So let's say I have y is equal to root of x, so same two functions, root of x divided by root of 1 minus x. Would the domain still be this? So clearly, I mean, we can only put numbers that we can put in both top and bottom. But there's one extra exclusion. Because it's divided, there's a fraction introduced. So we actually have to omit x is equal to 1 as well. Okay? So very similar, but it's 0 to 1, but not including 1. So when it's division, you have to do this. It is still intersection, but you have to omit x such that it'll make g at x equal to 0.